I'm Philip Pollock, and this is The Essentials of Political Analysis. You've probably heard this distinction before, and I'm just going to mention it here again briefly. You've heard the distinction between normative questions, what ought to be, and empirical questions of fact and causation, what is or what are the relationships. And once again, to reemphasize the point, no methodology can prove one value superior to another. However, the scientific method can help us determine whether one factor cause is more correct than another factor cause. So that's the province that we're dealing with in this book, is the province of empirical questions, fact, and the relationship between facts or causation. And, we are in the province then of the scientific method. There are really two principles to the scientific approach to political analysis or any analysis. Be transparent. Be transparent in the measurements you make. Be reproducible in the way you describe phenomenon, so that anyone doing what you did would reach the same conclusion about a measurement, for example. We deal with open, reproducible, and accessible measurements and data. And of course, be dispassionate, like science is. Dispassionate in reporting data and findings. Don't get, I guess you might say, invested in finding a certain outcome. Be open, transparent. And the other side, what transparency really requires for its completion is to be skeptical and allow skeptics every opportunity to test the ideas that you find. Skepticism. Those who challenge and question findings are given a full and complete hearing. We've got to be open, there's the openness idea and also the skepticism idea in science. And if these two principles are followed, then we end up with a very constructive dialogue as we seek the truth in terms of causation and relationships that we see in politics. All right, now let's talk a little bit about the kinds of questions, kinds of tasks, I guess you'd say, that are before us here. There are what questions, and there are why questions. Again, the first part of the book is about what questions. How do you define a concept, for example? We have a lot of very important and complex concepts in politics. One of my favorites that you'll see in the book several places is the concept of political tolerance. What is political tolerance? When you say that person is politically more tolerant than that person, or that group is more tolerant than that person, what do we mean by that? See, this is like the first thing we have to tackle. What is it? What is political tolerance? If we can define it conceptually, we also must measure it empirically. Why questions? In a lot of ways, these are more fun, if you will, because we get to construct explanations for why are some people more tolerant than other people after we've measured it correctly or properly in a way that others accept, and then we can develop explanations. Why do some people have higher levels of political tolerance than do other people? It's a good question. We can answer such questions if we're clear about our measurements. What questions? Description. Scientific facts are based on empirical observation and measurement. Scientific facts are reproducible. Again, repeating the theme about science. We don't use mysticism, intuition, ideology. We don't use anecdotal evidence to support our or to test our hypotheses. We don't cherry pick data that supports our hypotheses. So we're based on empirical observation and measurement. And of course then, as I'm sure you've heard before, scientific facts are reproducible. They can't just be one-offs, so to speak, where you just find one thing and then it can't be reproduced. There has to be a method. Facts are described in such a way that anyone else following the same procedure would get the same result or make the same observation. Now, why questions? Why questions are, as I said, more fun in a way. They're also more challenging. why questions have to be framed in such a way that they invite us to think about a process. Science looks for causal processes. It describes how one fact causes another fact, and when you start looking at the connection between two concepts, and you start to drill down into that connection, it's really a rich soil where you find all sorts of processes that elucidate the connection between the facts. For example, this is what is called an acceptable explanation. Because the educational experience exposes individuals to diverse ideas, people with more education are more tolerant than those with less education. This is an acceptable explanation because it invokes or references a process by which one set of facts, the educational experience, is tied to another set of facts, the levels of tolerance. Now, if I were to pursue this explanation, I would have to, again, open up the idea of educational experience and describe more fully why it is that the educational experience, according to my explanation, is more likely to produce tolerant political outlooks. Now, one more point on this. This explanation is acceptable. That doesn't mean it's correct. It doesn't have to be correct. It has to be testable to find out if it's correct. And that's the criterion of an acceptable explanation, testable. Unacceptable explanations lack process. And this explanation here is silly on its face, but it does make the point. People born under an earth sign are more tolerant than those born under a fire sign. The idea behind what makes this unacceptable is it's not testable. And more than that, it doesn't have a process. There's no process implied by this. So this unacceptable explanation. So when you start constructing explanations for phenomena, you should always think about the process. How does one set of facts cause another set of facts, and what's the process behind that? And of course, to reiterate the themes of this chapter, scientific knowledge is testable. The researcher describes a set of conditions under which the idea would be rejected. You probably have heard about the falsifiability principle before, and here it is again. If I'm going to test an explanation or a hypothesis, I must also be saying, here, if I find this set of results, I will reject my idea, or I will go back and reconstruct the explanation, maybe taking the new data into account. A researcher with a testable idea is saying, if I am correct, I will find such and such to be true. If I'm incorrect, I will not find such and such to be true. And therefore, I will say that I'm incorrect if I don't find what I hypothesized to find.